Hey, Franklin West. I hope you're all doing really well. This is part two of the Factoring Trinomials series. And this video is all about the thinking we need to do and the questions we need to ask ourselves about how to factor a trinomial so that we can get it into its binomial parts. And this is focusing only on trinomials that have all positive terms. So hope you enjoy the video.
That's about uncovering the thinking needed in factoring trinomials. And this video is focusing only on trinomials that have only positive terms throughout. So if you take a look at the bottom of the screen right here, that's for trinomials that look like this, where it's a positive b squared, a positive middle term, which is 8b, and a positive last term, which is the 7. So here's the thinking. This beginning part to introduce this feels a bit more like a puzzle or a game, so to speak. And so it's almost riddle-like. So we have two numbers, A and B, and we're going to add them together and see what they equal. And then we'll take those two numbers, A and B, and multiply them together and see what they equal. So when we're looking for the result of adding, that's the sum. And when we are looking for the result of multiplying, that's the product. So for every pair of numbers A and B, we're looking for their sum and their product. Okay, so excuse me. So I already have two numbers A and B listed in this column. For each one, let's find their sum and product. So 3 plus 1 is 4. Their product, when you do 3 times 1, is 3. So you can see how 3 and 1 get us a 4, and depending on how you use them can get you a 3. And 4 plus 7 equals 11. But when you multiply 4 and 7, you get a much bigger number. You get 28. Try to do these before I do them. That'll be good mental math practice. So 5 plus 2 is 7. But when you take 5 and 2 and multiply them together, you'll create a 10. And 2 plus 3 is 5. But when you multiply those together, you get a 6. 5 and 7 added together, the sum is 12, and their product is 35. 1 and 1, when you add them together, gets you a 1, but their product, when you multiply them, remains the same, an identity of 1. And 2 plus 4 added together, we get a 6, but multiplied that 2 and 4 together, we get an 8. Okay, so this is really just something we already knew, but now let's see how this thinking applies or helps us as we move toward this table, where here we're working in the opposite direction. Here we have sums provided for us and their corresponding product. And so what we have to do is think about what are those two numbers, A and B, for like if we match this thinking here, what are two numbers that created those sums and products? So for example, when you take a look at 10, well, that could be from 0 plus 10. It could be from 20 plus negative 10. It could be from 8 plus 2. So there's actually an infinite amount of pairs you could make to create the sums. But what locks us into which particular pair we need comes from the product here. So we have two numbers that add to 10, but they also have to multiply to 25. So that would be 5 plus 5 multiplies to 25. And so that is what guides us here, that those two numbers are 5 and 5. Here we have 16, two numbers that add to 16. Again, there's an infinite amount of possibilities, but we need the two numbers that we choose to also, that when we multiply them, multiply to 64. So that would be, maybe you can tell me before I do it, 8 and 8. So let's take a look at 11. And this won't happen every time where the two numbers are identical. That's just the way they look right now for these two examples, but that's not always the case. So when we take a look at 11, two numbers that add to 11, well, you could do 3 and 8, but when you multiply 3 and 8, you get 24. You could try 10 and 1. They add to 11, but when they multiply, they get 10. So the two numbers we need must be 9 and 2. because we need them to multiply to get 18. So hopefully you're starting to feel the sense of the thinking that's involved here. We're really trying to do informed guesswork on what two numbers we need based on how they add and how they multiply. And just so you know, this is a trial and error part of your math, and to get it right, wrong, and then finally right is actually a very normal part of this process. So don't think for a second that if you don't get it right the first go, that you're terrible at this and can't do it, because that's just not true. Even your teachers might have to look at some of these pairings a couple times and play with numbers in their heads or out loud in order to get the right pairing. So just know that trying and doing over again maybe a few times is just normal for the process. So now when we take a look at the sum for 11, I think I used it as an example from above, but the two numbers that we want are 10 and 1, because 10 plus 1 is 11, but 10 times 1 is 10. Okay, so that's how we approach this. So when we take a look, how does this all matter, you might ask? Well, it has to do, I'll go to a different color. It has to do with these positions. So if you take a look down here at this 8b, when we remember that how we got that through distributing two binomials together, this came from the two terms that were like terms that we added together. So that 8 came from a summing event, right? From adding. That's our sum. So that would be like in this column here. So we ask ourselves, well, what two numbers would add to 8? And then here from the 7, if you think back to your two binomials distributed together, this was from the two last terms of those binomials being multiplied together. That was a product, right? This is where two numbers multiplied together to create 7. And so we ask ourselves, notice how similar these questions are. In this particular problem, we ask ourselves, what two numbers add to 8 and multiply to 7? And so that's kind of the riddle thinking that you do when you do this factoring of trinomial work, is you're always asking yourself this question specific to the problem in front of you. So whatever is the coefficient of the middle term, you ask yourself, what two numbers add to this value? And then for the last number in the trinomial, you ask yourself, what two numbers would also then multiply to this number. And then that tells you your mystery numbers when it comes to factoring. So when you take a look at 8, two numbers that add to 8 but multiply to 7, hopefully you said 7 and 1. And so that would give you a final factored form of x plus 7. Oh, look what I did. I went to x's b's. B plus 1. Okay, so when I distribute b times b, so the b squared is always going to be split up in that way. B times b. B times 1 is 1b. 7 times b is 7b. So 7b plus 1b is 8b. And 7 times 1 is 7. So that's the thinking. I'd like you to start practicing and get in the habit of asking yourself that question. What two numbers will add to such and such and also multiply to such and such? Good luck.
Well, I hope you found that video to be helpful for what you needed. Never hesitate to reach out to let me know how you're doing and what topics you would like to see next. And as always, do your best, get your work done. You're all wonderful people. Have a great day.